Okay, this question is all about loci in the Argand diagram. And just to give a little tiny bit of background, so we are given that the modulus of this expression here has got to be less than or equal to 2 root 2, and we are also given that the argument of z plus 1 has got to be between pi over 4 and pi over 2. So what are they talking about? Well, let's just sort of, if we look at a circle in the Argand diagram, okay, and let's just draw the Argand diagram somewhere. So this is the real and this is the imaginary, and here is the centre of that circle there. Let's call the centre of that circle the complex number A, and the radius, let's call it R. Well, Z, which is the complex number, Z minus A, the modulus of Z minus A equals R, represents this circle. What it means is the distance between Z and the centre of the circle, A, is always R, the radius. So if we were to change that to the modulus of Z minus A is less than or equal to R, it is representing, in the Argand diagram, it is representing the shaded area like this. So if it was less than, it would not include the actual circle surface, and if it was less than or equal, then it would. Now, what about the argument? So let's imagine that we have this circle here. Well, the minimum argument of Z would be this argument here. That would be the minimum argument, and the maximum argument of Z would be this angle here. So if Z was to, for example, be between whatever, let's say pi over 4 and theta, then they would only be referring to this part of the circle. So that's what we're trying to do. So let's go to the actual question in hand. And just before we do that, what we need though is we need this first expression here to be in the form Z minus A less than or equal to R, so that we can draw the circle. So we've got a little bit of work to do before we can get it into that form. So let's go on that. So we got here modulus of Z 1 plus I add 3 minus I is less than or equal to 2 root 2. So we've got a little bit of work to do. Now, how are we going to get this Z on its own? Well, let's multiply that second expression by 1 plus I. So add 3 minus I times 1 plus I over 1 plus I. So we haven't actually done anything. All we've done is multiply top and bottom by 1 plus I, which means that we can now take out 1 plus I from that expression, leaving us with Z plus 3 minus I over 1 plus I, and the modulus of all of that less than or equal to 2 root 2. Now, we know that modulus of AB equals mod A mod B, and so therefore we can split this into mod of 1 plus I times mod of Z plus 3 minus I over 1 plus I less than or equal to 2 root 2. And remember, what we're trying to do is we're trying to get it into the form of mod Z minus A is less than or equal to R in order that we can draw the circle. So we're getting there, but we've still got a little bit more work to do. Let's have a look at this expression here. 3 plus I over 1, 3 minus I over 1 plus I. Well, we need to get rid of the 1 plus I on the bottom by multiplying by its conjugate, 1 minus I on the bottom, which gives us, that's 4 minus, sorry, I'm getting lost here, 3 minus 4I minus 1 over 1 minus I squared, which equals 2 minus 4I over 2, which equals 1 minus 2I. Okay, so we can therefore replace this expression here by 1 minus 2I. So we now have 1 plus mod of 1 plus I mod of Z plus 1 minus 2I less than or equal to 2 root 2. And we're almost in the right form now. Mod of 1 plus I is root 2, because that's 1 squared add 1 squared, the square root is root 2. So we can write that as root 2, and at the same time let's just make this Z minus, so we just have to go minus 1 plus 2I is less than or equal to 2 root 2, so that when we, this is exactly the same as it was before, we've just put in the form of minus. So now we have that the root 2 cancels, so we have Z minus, bracket, minus 1 plus 2I is less than or equal to 2. And finally, we have the first equation in the form that we wanted it. So now what we can do is we can draw this circle on the Argand diagram. So let's draw a circle. Okay, so there's the circle. And we know that the centre of the circle is -1 plus 2. So there's the centre of the circle, -1, 2. Which means that and we know that the radius of the circle is 2. So therefore we know that this point here is 1, 2. And we know that this point here is -1, 0. So we can actually now draw our axes. There's our real, and here is our imaginary, and here is our circle. Now I won't draw it because otherwise it's going to get confusing. But we want the modulus to be less than or equal to 2. So basically, what this is saying is it is saying all of the part of the circle, everything that is inside of that circle, is basically represented by this equation. Now, what about the second part of the equation? We haven't dealt with that yet. So the argument of z plus 1 is greater than or equal to pi over 4 and is less than or equal to pi over 2. So how do we draw this on the equation? Well, z minus 1 is this point here, and we need the argument of z minus 1 to be greater than pi over 4. Well, if we just look at this line here, between here and here, this distance here is 2, and this distance here is 2, so that angle is indeed pi over 4. And it's got to be less than pi over 2, which is basically that point there. I should have drawn that a little bit better, sorry. And that's pi over 2. So basically what it is saying is that the two equations are representing this point here, this area here, which is the area which is inside the circle z 1 plus I add 3 minus I is less than or equal to 2 root 2. And the argument of z, and remember the argument of z is going to be greater than or equal to pi over 4 and less than or equal to pi over 2. So it is this area here that it is representing. Now the question, let's go back to the question. What's the question actually asking? The question is asking what is the range of the argument of z? So z is basically every single point within this area here. So, but z is always calculated from the origin, not from the point -1. So let's have a look at z here, and let's try and do it in a different colour. So basically z, that is the minimum argument of z is here. And then z will go all the way, all of these points are represented by z, all the way across here to this point here, which is pi over 2. So the argument of z, we have to now look at this triangle here. Let's try and draw it. We have to look at this triangle here, okay, where this distance here is 2 and this distance here is 1. So therefore that angle there, theta, is tan to the -1 of 2. So z has got to be greater, the argument of z has got to be greater than tan to the -1 of 2, and it's got to be less than pi over 2, which is the angle all the way to there, pi over 2. Sorry, pi, less than pi, sorry. So basically when the range of the argument of z under the two constraints, i.e. it's got to be within that circle, and the argument of z minus 1, the argument of z plus 1 has got to be between pi over 4 and pi over 2. The range of the argument of z is basically that the argument of z has got to be greater or equal than tan to the -1 of 2, which is this angle here, and it has got to be less than pi. The reason it's got to be less than is if we just look at this here, when z equals -1, that means that we have nothing here, and so the only time that the angle would be pi over 2 would be when z actually equals -1 and there is no argument to calculate, and so therefore argument of z has to be less than pi, not less than or equal to pi. And so the answer to the question is that the argument of z must be between tan to the minus 1 of 2 and pi.